Hi everyone, welcome to first edition of the Fullstack GraphQL Book Club. Today we are doing something a little bit different on the Neo4j stream. Instead of building an application, we're going to be reviewing the first chapter of the Fullstack GraphQL Applications with GRANDstack book. Hopefully everyone did their homework. If not, no worries. So the plan for today is to take a look at chapter 1 of this book and then sort of work through the exercises at the end. And we'll continue that and go through each chapter in the book. If you have any questions or thoughts as we're going along, feel free to drop those in the chat. Let's try to make this as interactive as we can. So first off, what is this book that we're talking about and how do we get it? I've been working on writing this book, Fullstack GraphQL Applications with GRANDstack, for a while now. It is in early release from the publisher, so grandstack.io/book. So it's an early release from Manning. There's currently 5 out of 9 chapters out. 2 more will be coming very, very soon, I think. But Neo4j has sponsored a 3-chapter excerpt of this book. So if you go to this URL, which I'll drop in the chat, so bit.ly/fullstack-graphql-ebook. This will take you to a page where you can download a 3-chapter excerpt ebook sponsored by Neo4j for free. And this is the version of the book that we'll be working through. So this excerpt, this includes chapters 1, 3, and 4. So that's what we'll be doing on the book club. So the idea is download this 3-chapter excerpt and then we can work through these together. So that's what I have on the left here. This is the PDF of this 3-chapter excerpt that anyone can download for free. Cool. So again, if you have any questions or thoughts, drop those in the chat. Otherwise, we will just jump into it. So a little high level sort of overview, I guess, of what this book is about and who's the target audience. So I've spent the last little while working with integrations with Neo4j. So how can we use Neo4j with other technologies? And one of those technologies that we've been looking at using with Neo4j is GraphQL. If you've followed any of the streams that I've done previously, we've built a couple of applications using GraphQL. The previous one was a travel guide using Gatsby and some of the routing functionality in Neo4j. That is here, which I'll drop a link to in the chat. So we called it Central Park. So this is using an OpenStreetMap data set in Neo4j to show points of interest and routing in Central Park. So we built this using Neo4j, GraphQL, and Gatsby. And then previously we built a real estate search application that we called Willow. So searching for houses and looking at some statistics and analytics of the housing market. That one is available on GitHub as well. I'll link that, and all of the recordings of those sessions are here. So anyway, so that's one of the tools that we've been looking at that we can use with Neo4j that helps us build applications using Neo4j, right? So Neo4j is this very powerful graph database, and we want to be able to expose those features in our application. There's a really nice GraphQL integration for Neo4j, and that makes it easier for us to expose the awesome functionality of Neo4j and graph databases in our applications using GraphQL. So that's really, I think, the motivation for this book that I've been working on. I think the target audience for this book is really myself, maybe several years ago in my career, when I was starting out as a web developer, and I worked at a startup, and essentially we had to build a web application around this core product. This was a fintech startups. This was like some financial trading application. The core technology of that financial algorithm was there, but we needed to expose it through a web application. And if I had known about GraphQL and GRANDstack, well, I should say if it had existed at that time, these are the tools that I would have wanted that would have made my life as a full stack developer a lot easier. So I guess that's really who I wrote this book for, is looking back. Okay, you want to build a full stack application that is maybe a bit data intensive. Maybe the data model of your application is a bit complex. Maybe you want to do some data intensive operations in your application. Maybe you want to add recommendations, personalization as part of that. What modern tools do you want to use to build that? So anyway, so that's sort of the audience and the motivation. And if we jump into it here, so these are the 3 chapters that are covered in the book. So what's the GRANDstack in chapter 1, which is what we're going to talk about today. It's just an overview of the components, GraphQL, React, Apollo, and Neo4j database. And then chapter 3, graphs in the database, which is a deep dive into Neo4j and the different Neo4j tooling that we'll use, talking a bit about data modeling with Neo4j, and then Cypher, the query language for Neo4j, and then also looking at how do we use the client drivers for Neo4j. So this is important. How do we build applications that talk to Neo4j? In this case, we'll look at JavaScript. And then chapter 4, how do we build GraphQL APIs backed by Neo4j? So we'll take a look at the Neo4j GraphQL integration in that chapter. And so that is the 3 chapters included in the excerpts. That's what we'll be covering in this order. So we'll skip chapter 2. Chapter 2 is a deeper dive on GraphQL. So I think we can kind of supplement some of that. I think that should be okay. But anyway, so that's the goal for today is to review chapter 1, so the different components of GRANDstack, and talking about how they fit together, and then work through the exercises. I think this forward says exactly what I was saying before, is sort of who is the target audience. Well, it's sort of me as a web developer building an application. Question from the chat: was the company using Neo4j as the main database? So this is so the example that I gave was when I worked at a fintech startup several years ago. And I needed to build the initial web application, and we were looking at evaluating technologies and figuring out what that stack looked like. And so the question is, was that company using Neo4j as the main database? No, it was not. I was trying to introduce Neo4j. This was many years before I worked at Neo4j. The startup was a fintech that was looking at options pricing and options trading strategies. And so most of the operations that we did were in-memory sort of financial algorithms. So looking at volatility curves for financial instruments. So most of what we did was sort of in-memory. It was a large Java application for connecting to some of those financial data feeds. I did build a options trading proof of concept, or options pricing proof of concept using Neo4j, which we did not end up actually using, but it was a fun proof of concept. I should dig that out somewhere. Cool. So so starting off here at chapter 1, what is the GRANDstack? Well, the GRANDstack is GraphQL, React, Apollo, and Neo4j database. You can, of course, use these technologies independently. You can substitute other front-end frameworks, other API layers, and so on. But I think there's something really special about this combination of technologies. There's, I think, this symbiotic relationship really between GraphQL and graph databases like Neo4j that we'll talk a bit about. GraphQL, I think, is a game changer for how we think about interacting with APIs. And React is a great front-end UI framework. And combined with Apollo, we have lots of great developer experience tooling for working with GraphQL both on the front end and on the back end as well. So I think there's something really special about this combination of technologies. Question from the chat. Curious how to do user auth in GRANDstack. Would be nice to have an example other than using auth0. Yeah, that is definitely something that we'll get into. I should say it's something that the book gets into. There's a chapter in the book focused specifically on authorization. So how do we create users in the database? How do we protect resources in the API? So it's definitely something that we need in any real world application, and definitely something the book dives into. I think that's in chapter 7, I think. Let's take a look. Yeah, so chapter 7, adding authorization, which is not in the early release yet. I have written it though. It's just currently being edited. So yeah, something we can dive into. Another question, do you plan to include Vue as an option for the GRANDstack starter? Yeah, that's a great question. So the GRANDstack starter project, let's just take a look at that. So the GRANDstack starter, basically, we just run this command, npx create GRANDstack app, and this will provision a GRANDstack application for us, including both the API layer and the front end. And then we have our choice of front end implementation. Either currently we have React, React TypeScript, Flutter, and Angular, I think, are the implementations. And your question is, are we going to do Vue? And yes, someone has written a Vue version of this. I think we just need to merge the pull request and get that updated into the CLI. Yeah, so my colleague Adam has written a Vue example. So if you dig into that, it's in there now on his fork if you want to play around with it, but we'll definitely be including that in the starter soon. Cool. Another question from the chat: is GRANDstack scalable, or is it just a starter framework, like a single page app? Yeah, so scalable, there are different dimensions of scalability, right? So I guess I would ask, depends on what kind of way you're thinking about scalable. If we're thinking of GRANDstack as scaling in the sense of addressing lots of different use cases, and is there, say, like a generator for generating components and things like that within the framework? Fundamentally, GRANDstack is a collection of technologies and a way of building applications, right? There's tooling that makes it easier to use these these technologies together, and things like the Create GRANDstack app CLI that helps us bundle these together. If we're thinking of scalable in the sense of the amount of data that I can work with and the amount of maybe concurrent users that can be querying my application, Neo4j is an extremely scalable database. We can deploy clusters of Neo4j, so multiple instances of Neo4j that allow us to scale out the throughput of our application. For the API layer, is that scalable? Typically when we're starting out, we look at running Apollo server as an express application. We can deploy those as serverless functions, which can then scale in the cloud. So anyway, there's lots of different ways, I guess, to think about scalability. But I would say, the answer to your question is yes, probably. I again think of GRANDstack as a starting point, I guess, of how these technologies can work together, and then we can often plug and play and massage different things depending on our use case, right, and how we want to address the scalable aspects. Cool. So, how do these fit together? If we look at this diagram here, fundamentally what we have is Neo4j, which is our database. Neo4j is a graph database. We query it using the Cipher query language, which we'll take a look at in a moment. GraphQL is the API layer that sits between the client and our database. So in our GraphQL server implementation, we're going to be generating Cipher queries to send to the database. So we don't send GraphQL queries directly to the database. Instead, it's the responsibility of our GraphQL server, our API layer, to figure out how to talk to our database. And then on the client end, we use React and build our user interface that way. And you'll notice here we have Apollo both on the client and the server. So Apollo is really this suite of tools for building GraphQL servers and GraphQL clients. And then Apollo also has a hosted solution that makes it easier to work with GraphQL across teams in the enterprise. That includes things like a schema registry, performance monitoring, and things like that. But we'll be focusing at looking at using Apollo clients and Apollo servers. So Apollo clients integrates with our front-end framework, in this case React, but there are lots of different flavors of Apollo client for different front-end frameworks. And the nice thing there is that it's idiomatic to the framework that we're using. So in React world, this means that we have Apollo hooks that allow us to basically bind state variables in our components to GraphQL queries and mutations, different GraphQL operations. So we can work with that data in our React components. And we don't really have to think much about how to connect to and serialize and send queries. Apollo client handles that, as well as caching for us. And then on the server side, Apollo server is a great tool that allows us to take our GraphQL type definitions, which is the schema that defines our GraphQL API, and the resolvers, which is the logic that says how to go out to the data layer to fetch data to resolve our GraphQL operations. Apollo server allows us to combine these together and create executable GraphQL schemas that we can then serve using different frameworks. In this case, we'll look at Express, but like I said, we can also push that out as serverless functions. Cool. So that's the basic way that these pieces interact. Let's take a look maybe at some of the individual components now. So by the way, GRANDstack.io, this is a good site that has links to documentation for using GRANDstack, including the create GRANDstack CLI that we saw for the Neo4j GraphQL integration that we'll talk about in a moment. Also, there's some low-code tooling specific to Neo4j Desktop that allows us to build GraphQL APIs. So you can think about those resources. There's also a GRANDstack blog that has cool posts from different folks in the community about the different ways that they're using GRANDstack and what they're building. So that's another good resource to check out as well. Cool. Yeah. So some discussion in the chat about different scalability. Yeah, I think fundamentally it comes down to, like I was saying, that there are different considerations, different aspects of scalability in any application that we want to reason about. Cool. Okay, so let's take a look at some of the individual components here, starting with GraphQL. So fundamentally, GraphQL is a query language for our API and really a runtime, I guess, for implementing that API. And with GraphQL, we start with type definitions. So we start with a schema that defines the types that are available, what are the entities, what are the fields on those entities, what are the types of those fields, how are these types connected. And that's where the graph in GraphQL comes in, right? Is that this the schema, these type definitions are defining a data graph, how these entities are connected. And while we like that there's a nice mapping between this data model that we think of in GraphQL, thinking in terms of a data graph, and the property graph model that we use in Neo4j, while there's a nice mapping there, we can use GraphQL with really any data layer. It doesn't have to be a graph database. We can work with relational databases, document databases, combining different data layers. It's often a common approach to wrap existing APIs, wrap REST APIs with GraphQL. So GraphQL is really data layer agnostic, I guess is the way that I think of it. So with every GraphQL schema, we define our type definitions, we define the entry points for the API, and then when the client issues a query, the client asks exactly what they're interested in and no more. So the client specifies what's called a selection set, and the selection set is this nested structure. Let's see if we have an example. Yeah, here's sort of constructing a selection set here. So you can think of a selection set as a traversal through this data graph. So this can be a nested structure. In this case, we're just grabbing individual fields, but we could also say, show me the name of the hero, and this is Star Wars data, so maybe show me the planets that this individual has been to, and then show me the species that live on those planets, that sort of thing, where we end up with this nested structure that's defining a traversal through this data graph, and then also which fields of those various types to return. And the benefit of the client being able to construct this selection set means that there's only one round-trip request to the API to render, say, a particular view in a application. So rather than with a REST API, where we might need to make multiple round trips, maybe if we're rendering a list of blog posts and their authors, first we need to go to the REST API and say, give me all of the blog posts. And then for each one, we need to go back to the API and say, give me the information on the author for this blog post. With GraphQL, we could do that all in one request. We talked about the benefit of the type system. And then, there's lots of great developer tooling that exists in the GraphQL ecosystem. A lot of it is powered by this concept of introspection. So once we have a GraphQL API, we can introspect the API and say, hey, what types are available? What is the schema of this API? And we can build tooling that allows us to view essentially as documentation the type definitions and the schema. So there's this tool called Graphql that we'll take a look at that allows us to view and search this introspection. And of course, we can also build things like suggestive autocomplete, type ahead, these sorts of features powered by this concept of introspection. That, I think, is a good overview at the high level of the benefits. The point here really is that GraphQL is really programming language agnostic. So there are GraphQL implementations in lots of different languages and frameworks. So maybe a look at some of the specific features of GraphQL. Yeah, so here we have a GraphQL query. So this is the Star Wars data from the previous page. And you can see it's sort of starting with this entry point. So hero, in this case, this is mapping to what's called a query field. So there's a query type that has fields. And so fields you can think of as like a property on an object. And here we're saying start at the hero query field and then find the name and return that. So fields are kind of like the building block, but we can create this more nested structure. So if we add the friends field to the query. This is bringing back a list of person objects, and then I can construct a selection set for that person object as well. Right, and so then I can continue on and say, okay, for each character, show me the episodes that they appear in, which is an enum. Cool, so that's how we can build up that nested selection set structure. We can also pass arguments. So here we're looking up a human by a specific ID, passing that in as an argument at the root. We can also have field arguments that are passed in as well. Aliases, we can alias the various fields in our selection set if we want to rename those. This is often useful in the context of our client application. If we maybe want to reason about certain pieces of our selection set differently in our client application, we find aliasing useful. Similarly, fragments. Fragments allow us to group a bunch of fields together and then reuse those. And again, I find this most useful in the client application where we have different views that may want to reuse different fragments. So rather than maintaining the individual selection set across different views, we can just define a fragment that groups a bunch of those fields and selection sets. Variables are important. Here's talking about variables and fragments. I think there's a separate section on variables. Let's skip to this one. So oftentimes in our client application, we'll have a static query, but then depending on some user input, the actual value for an argument is defined based on that user input. And so in that case, we define variables so that will be passed along with our GraphQL query. So in this case, the client is going to pass the query and then an object of variables that has values for the variables defined in the query. And it's important also that because of the strict type system in GraphQL, we have to define the type of those variables as well. So first we declare it. So here, this is the variable episode that is of type episode. And then where do we actually use it? Here we use it as an argument passed to the hero field. And when we define variables, we need to add the operation name. So by default, the operation type is query. There are also mutations and subscriptions, which we'll talk about as well. Okay, so that I think is a good overview of how we can use GraphQL. There is a example GraphQL API, which I will drop the link in the chat to, movies.grandstack.io. So this is the example that I think we'll use for the exercises. So maybe we'll just take a brief look at this and then come back to this when we start working through the exercises. So yeah, from the chat, Constantine is looking ahead and asks if we can sort by director name. Yeah, so we'll take a look at that when we start working through the exercises. But this is a good example API to look at for a couple of reasons. One, it uses what's called GraphQL Playground. So if we just connect to this, then if we just connect to this in our browser, we'll see this interactive GraphQL Playground tool, which is kind of like Graphql. We saw an example of Graphql previously on that graphql.org website. So we can look at the docs. So this is powered by that introspection feature of GraphQL. So we can see, okay, what are all of the entry points? What are the types that are available? So it looks like we have movies, genres, actors, and users. We can see how they're connected, the fields that we have available on each type, and so on. So I just wanted to point out that this API is out there. Play around with that. We'll come back to that in a minute when we start going through our exercises. Okay, so I'm going to skip through this section of the book. There's more in there that sort of compares GraphQL to how we might do things in the REST world, a bit about some data modeling and so on. So you can read through that in the book. I'm going to skip down to the React section, and let's talk about React for a little bit. So React is a JavaScript library for building user interfaces. React, like GraphQL, was open sourced by Facebook. React is often used for building web applications, but there are different rendering engines for React for, say, for example, for native. So for mobile applications, React Native. There's also React VR for building virtual reality applications. So not specific to talking about the web and the DOM, although that is a common way to use React. So in React, we typically use what's called JSX. So JSX is kind of this XML-like syntax that is sort of mixing JavaScript and HTML. It's not required, but we often find that JSX is a useful way to be able to construct our components. And so when we're talking about components, a component, I guess, is sort of a way of combining React elements and data. So there's two kinds of data in our components. There's props or properties, and these are values that are typically passed in to our component, typically from some other component. So components are often nested. We end up with this hierarchy of components to compose a more complex UI. And then we have state, and state is variables that are specific to a component that then can trigger re-renders of that component as the state changes. So one thing that is nice about React is it's very smart about trying to re-render pieces of our component, pieces of our application only as state is changing, only re-rendering the piece of the application that needs to be re-rendered. So rather than re-rendering the entire DOM for a web application, if only a small piece has changed based on its state, React knows to only update that piece of the application because it maintains its own what's called a virtual DOM, so a virtual model of the DOM. Let's take a look really quickly at a simple React application. So there's a command line tool called Create React App. And Create React App is a convenient way to get started with React because it bundles together lots of things we need for building a React application, so we don't have to think about things like Webpack. We can just have scripts that are opinionated and take care of that. So let's do npx, make this a bit bigger, npx create React app, and call it my new React app. So npx is a command line tool that comes with npm. So from the Node ecosystem, and npx basically combines the ability to download a package from npm and then execute it. So we don't have to install this create React app package. Create React app, this is a package that we can find on npm. So if we go to create React app, we'll see it on npm. But with npx, we don't need to install it. We can just say download the latest version of it and then execute it as a command line tool. And so what does it do? Well, it builds a new React application for us, in this case called my new React app. Let's open this up in VS Code. So question in the chat. As a developer, I'm transitioning from Windows Form VS environment to a VS Code open source developer. Setup and deployment is harder in the GRANDstack world. Could you call out any relevant differences between Windows Forms deployment and GRANDstack deployment? Yeah, that's a good question. Unfortunately, I probably am not the best one to answer that. The Windows form world is not something I know much about. But if anyone in the chat has any thoughts or opinions on that, maybe they could help Dennis out a bit. But yeah, not something I'm too familiar with. Maybe that might be also maybe a good question for the Neo4j community site, community.neo4j.com, which is a discourse forum. So lots of folks asking questions there, and lots of folks from the community giving their input. So that might be a good resource to ask that question, and we can give you a bit more info than what I can. Okay, cool. So we have created our React app. We've opened it in VS Code, and let's get a terminal. And let's run this. So yarn start. If we take a look in package.json, we'll see that there are only a few dependencies here. So this React scripts depend. So first of all, React and React DOM. So React is the core library. Version 17, I think, is very new. So that's great. We've got the latest version of React and React DOM. So we said that there are different rendering engines for React, that we can build our user interface and then use a different rendering engine for that on different platforms. So React DOM, this is the rendering engine for the web. So the DOM, the document object model. There's also React Native, React VR, but this is specifically for building web applications. And then React Scripts is where we have all of our sort of build tooling that we get through Create React App. So when I ran yarn start, it did a React Scripts start. Let me zoom in a little bit. There we go. Similarly for build, so when we're ready to build this and deploy this somewhere as static content, we can leverage React Scripts build to do that. So when I ran yarn start, it did React Scripts start, and as it says here, it built a dev version of the application. So that means that I'm going to have hot reloading as I make changes to the application, and then is serving that on localhost 3000. So let's take a look at what we got there. And cool, we've got this application with a spinning logo and some text. It says edit source app.js and save to reload. So let's take a look at this application. So in source, first let's look at index.js and see what's going on here. So here we're pulling in React, React DOM, some CSS, pulling in this app component. So app is a React component. And then we're calling React DOM render, which is then going to render our entire React application, the entire React component hierarchy that we defined here. It's going to render that into an element in the DOM, in this case with ID of root. So there is this index.html file, which here has this div with ID root. So when we say in index.js to render our React application into that element, that's the one that we're talking about. So that one in index.html, render our React application into that element. What are you going to render? Well, we're going to render this app component. We wrap it in this React strict mode, which gives us some more opinionated linting. Okay, so let's switch to app.js and see what this looks like. So we're pulling in an SVG logo and some CSS. And then here is our component. So components are just functions. Previous versions of React more heavily relied on what are called class components. So when we start working with state, so we said earlier that there's two kinds of data inside a React component, props or properties and state. We said that props get passed into our component, typically from some other component in the hierarchy, and then we work with that props data to render that somehow according to our view logic. And then we have state. And state, these are variables inside our component that are changing perhaps, and when a state variable changes, then that can re-render part of our component. So previous versions of React required you to use what are called class components to work with state. However, more recent versions of React have introduced what's called hooks, which allow us to have state variables inside functional components. So we can still use state class components to work with state, that's fine, but we can also just keep our React components as functions and just work with state using hooks and have functional components. Anyway, let's modify this this component a bit. So what it's doing, there's one component, app, which is this function, and it's returning a div and a header and our image and some text and an anchor tag. So let's modify this now. Let's create a new component. Let's call this greeting. And we said that in React, components are just functions, and functions that are passed props specifically. So let's say that our greeting component is going to take a name prop, and what we want to do is return just a div that includes the name and a greeting. So we'll say hello, name. And then here we can use that component inside our app component. So components are nice because they allow us to encapsulate data and logic and can then be reused. So here I'm including this greeting component, and now I have hello blank. So let's pass a name prop. Oops, misspelled Will there. Will with 2 L's. So now I have this greeting component that I can use here in my app component, and I can feel free to reuse it in other components as well. Okay, so that's a brief look at React and the Create React App CLI, a bit of a look at JSX, components, and props. Let's move on to the next piece in our GRANDstack list of components here, which is Apollo. So Apollo, let's start at apollographql.com. So Apollo is really a suite of tools for working with GraphQL, both on the client, on the server, and then also tooling for things like testing. GraphQL API is working with GraphQL in a large team. And if we look at, actually I want Apollo, not React. Oh yeah, platform. That's what I was looking for. So the Apollo platform. Let's take a look first at Apollo Server. So Apollo Server allows us to take GraphQL type definitions and resolvers. So here's an example. Let's skip ahead to step 3 here. So in this example, we are defining our GraphQL types using the schema definition language for GraphQL. So we skipped over this a little bit. We'll come back to this. I think we have an exercise that we need to think about how to create GraphQL type definitions. But the idea here is that we are defining our types. So here we're saying there's a book. Book has a title of type string and an author of type string, and then a query type, which defines the entry points for our API for read operations. And we're saying you can query for books that will give you a list of book objects. So we start with the type definitions for our GraphQL API. Then we create resolvers. So here we have just one field resolver to implement on the query type. That's books. And in this case, I think above we've defined, so above we've defined just some hard-coded data. And here we're just returning that books array. But this could be something more complex, like query a database, query another API. And then Apollo Server allows us to combine those type definitions and resolvers. It gives us an Apollo Server instance that we can then, in this case, start an express server that is then going to handle the networking layer. So taking GraphQL requests and executing those against our GraphQL executable schema. So that's at a high level what Apollo server is doing for us. And then on the client side, so if we go to platform, Apollo client, on the client side, let's see, we can zoom in a bit. Yeah, this is a good example. So the default Apollo clients integration is, I think, the React hooks integration at this point. So what's nice about this is that it hooks in to our state variables in our React components. So here we have a username React component. We're defining a GraphQL query operation here using the useQuery hook. So here we're querying the me query field, fetching the username, and then when our data comes back from the GraphQL API, it's populated in this data object down here, so which we can reference data.me.username and render that in our React component. Apollo Client does lots of other nice things for us, like maintains a cache, so we don't have to go out to the GraphQL server with every request, and has some other hooks as well, so we can say only execute a query when we are responding to a user operation or working with mutations for write operations. There are different flavors of Apollo Client. So this is the React framework integration, but there are integrations with other front-end frameworks and also native for iOS and Android. Okay, cool. So that at a high level is some of the benefits of Apollo. Let's take a look now at Neo4j. So Neo4j, let's jump to neo4j.com, the developer getting started page. This is a good place to start. Okay, so far, let's take a look at our GRANDstack. We have a diagram. Yeah, here's the diagram. So far, we've talked about React, the front end layer for our application. We've talked about the GraphQL piece, both how we query GraphQL on the client and how we can build a GraphQL API using Apollo server. What we haven't talked about is our data layer in the application, and that is where Neo4j comes in. So Neo4j is a native graph database. So what that means is that the data model that we work with in Neo4j, unlike other databases where we may be thinking in terms of tables or documents, instead the data model is a graph. So nodes, these are the entities in the graph, and relationships connect nodes, and nodes and relationships can have properties or attributes. That's sort of the basic data model. And there's, like I said, a nice symbiotic relationship when we're using GraphQL and Neo4j together. And in one sense, what I mean by that is, well, there's a nice mapping from the data model that we have with GraphQL, thinking of this data graph and mapping that to the property graph model that we have in Neo4j. But there's also benefits that we get for Neo4j using GraphQL. And one of those, I think, is this idea of a strict type system. So Neo4j itself is what's called Schema Optional. And what that means is that we don't have to define a strict schema to start working with data in Neo4j. So we can just start creating and querying data in Neo4j without defining any constraints on if certain properties should be of certain type or if they should even exist at all. And this can be a good thing, or it can also sometimes be a bad thing. So, for example, it's nice to have this flexibility and the ability to evolve our data model without having a strict schema, but it can be difficult to then sort of reason about that schema and enforce that, say, maybe in our application layer. But the benefit that we have of working with GraphQL in Neo4j is that GraphQL then enforces that schema for us through its type system. Is one of the benefits, I think. So what is Neo4j? Really, let's talk a little bit more about that. We said Neo4j is a database, but Neo4j is really more than that. The database is really, I think, just the core part of Neo4j, and there's really this platform, this ecosystem around Neo4j. And I think there's kind of this spectrum of two ways to use Neo4j. One is in a transactional manner, so thinking of graph transactions, I guess, as this says in the diagram, but basically where Neo4j is backing an operational workload. So we're building maybe a movie search application, a business reviews application, something like that, where we're executing operational workloads against Neo4j, create this user in the database, find this user in the database, find the restaurants that they've reviewed, and so on. And the benefit that we have in that use case with Neo4j over other databases is a few things. One is we have this graph model, which is really nice for expressing connections amongst our data. So if we're talking about business reviews, it's very natural for us to be able to model and express a query that is touching users, the reviews that they've written, the businesses that are mentioned in those reviews, their friends that have reviewed the same businesses, what genres those are in, and so on. And if we're doing queries that are touching a lot of those, so maybe traversing from a user to their reviews, to the business mentioned, to the genres, to their friends that have reviewed the same genres, that sort of query is a traversal through our data graph, right? Which we can express in GraphQL or we can express in Cypher, which we'll take a look at Cypher in a minute. But the benefit that we have with a graph database over, say, a relational database or a document database is it's easier to express that in the query language for the database. So Cypher, which we'll see in a minute, allows us to just essentially draw this sort of ASCII art notation for this sort of traversal. And then the other is the performance implications. So graph databases like Neo4j are optimized for these traversals. So databases like Neo4j have this property called index-free adjacency. And what this means is that traversal from a user to the reviews they've written, to the businesses mentioned in those reviews, to the genres, to their friends, is never hitting an index to do that traversal. So each one of those traversals is a constant time operation. It's not dependent on the overall size of the data. So that means that as we add more and more data, so this is getting back to some questions earlier where folks were asking about scalability. This is one dimension of scalability, that I think is really important is that as we add more and more data, more businesses, more reviews, more users, going from one user to their reviews to businesses and that traversal is a constant time operation, dependent really on the number of businesses that are connected to that user, not the overall size of the data. So we're going to have different performance characteristics in a graph database like Neo4j versus trying to do that operation in a relational database where each one of those traversals is a join against a join table, where we're using an index that is going to slow down as we add more and more data to the database. So anyway, so that's the graph transactions side of using Neo4j for more operational workloads. And then we have this right-hand side that's talking about graph analytics. And these are the more global operations. So rather than looking for a specific user and finding, the reviews and recommendations for that specific user, when we're talking about graph analytics, we're talking about operations that are touching the entire graph. So can we run PageRank on the graph to find the most influential nodes in the network? Can we run community detection on the graph to assign nodes to different communities and that sort of thing? And there's lots of tooling that is available for these more analytics and global use cases. So things like the Graph Data Science Library, which has lots of these graph algorithms. Bloom, which is a tool for data visualization, sort of a low-code tool that allows us to visualize and work with our data. So when we talk about Neo4j, we're really talking about not just this core database, but really this platform of tools that sit around the database. We didn't really mention things like tools for data integration, but of course these exist as well. Neo4j does not just exist in a vacuum. We need to be able to, say, integrate with Spark or Kafka, ETL tools for importing data into Neo4j. So we have those sorts of tools and integrations, and then client drivers are really important as well. So we're about to take a look at Cypher, which is the query language that we use to interact with Neo4j, and you often want to build an application in lots of different programming languages, so Java, JavaScript, R, whatever it may be, and you want to be able to send Cypher queries to Neo4j, but work with the database in the language of your choice, and that's where the client drivers come in, which we will dive into in more detail, I think, in the next session. What I want to do now is talk a bit about Cypher. So Cypher is the query language that we use to work with Neo4j. Let's take a look at the getting started example. I just want to find some examples here. Yeah, so with Cypher, here's a good example. With Cypher, we're very much thinking about declarative pattern matching. So what does that mean? Well, basically what we do is we draw these graph patterns, and then we have some different commands that we can use in Cypher for how we want to operate on these patterns. But this idea of pattern matching is fundamental to Cypher. And what do I mean by pattern? Well, here, this example, we have defined a pattern that says one node with the label person. We'll bind that to the variable p. An outgoing relationship of type likes that is connected to a node with the label technology, and we'll bind that to the variable t. And this is a create operation. So if we ran this line, it would create two nodes in the database connected by a likes relationship. So that's what we mean when we talk about pattern matching in Cypher, is drawing this sort of ASCII art notation that defines patterns in the graph. Let's take a look at Neo4j Desktop. So Neo4j Desktop is, if we go to download Neo4j, so neo4j.com/download, desktop is the default download. You can think of desktop as kind of the, I don't know, mission control for working with Neo4j is maybe a good way to think of it. So I can create projects. I can create local or remote databases within each project. I can install graph apps, which are sort of like plugins and extensions for Neo4j Desktop. Maybe we'll talk about those in more detail again, I think, in the next session. So here I have a database with some data from OpenStreetMap. So let's open up Neo4j browser. So Neo4j browser allows us to write Cypher queries and visualize and work with the results. So this data set comes from the Summer of Nodes project that we did. Is anyone on the live stream who participated in Summer of Nodes? Let us know in the chat if you did. Summer of Nodes, I think, was a lot of fun. It was basically a series of challenges for working with different data sets. And this was, I think, the final one where we took some data from Central Park, from OpenStreetMap of Central Park in New York, and imported that into Neo4j, and then we extracted points of interest. So here's our point of interest nodes. If you're following along on the live stream for the, I know I posted a link to this earlier, but the Central Park project where we built a travel guide with Gatsby, this is the data set that we used for that project. And I'll drop the link to that in the chat again in case you missed it. But anyway, so I just want to show some examples of Cypher and Neo4j browser to give you an idea of how we can work with data in Neo4j. So let's make this a little bigger. There we go. So here's these red nodes. These are our point of interest nodes that we identified in OpenStreetMap. And we can see the properties that we're storing on these nodes. So this is the William Shakespeare statue, and we have its latitude and longitude. So OpenStreetMap it's all crowdsourced data. So someone went to Central Park, went to this William Shakespeare statue, figured out what the latitude and longitude is, uploaded that to OpenStreetMap, and they also gave us some additional information. So the name of the artist, the artwork type, the date that it was built, and this is really handy, is connected it to Wikipedia. So we know what is the Wikipedia page for this point of interest. So we have that data, but then we have all of the ways from OpenStreetMap that exist within Central Park, and ways are basically just the terminology for any geographical object that's been uploaded to OpenStreetMap. So this could be points of interest, this could be the outline of buildings, footpaths, sidewalks, streets, and so on. So we know basically not only the latitude and longitude of this William Shakespeare statue, we know all of the footpaths and sidewalks that we can follow to get, say, from one point of interest to another by following, in this case, these route relationships. So these blue nodes represent intersections in the different ways. So where do two footpaths or two sidewalks or a sidewalk and a street, where do they intersect? That then forms a routing graph that I can traverse to go from, say, from, I don't know, this William Shakespeare statue to this unnamed fountain, right? So let's see how we can do that in Cypher. So I'm going to switch over here to some saved queries. So first of all, can we find two points of interest? So here we're going to find a point of interest where the name is the Duke Ellington Memorial, and then find another point of interest node where the name is the Jacqueline Kennedy Onassis Reservoir. If we run that, yep, here's my two nodes. I can double click on these and see what they're connected to. So this OSM tags node is a node that has additional information from OpenStreetMap. And then I see our routing graph, our routing nodes. So these are the different intersections and the different ways that connect to the reservoir. Okay, so how do I find a path between these 2 points of interest? Well, one feature that's really nice in Cypher is this variable length path operator. So here I've said find the Duke Ellington Memorial, bind that to the variable A, find the reservoir, bind that to the variable B, and then this pattern, this says a path from A to B following the route relationships. So this is our routing graph connecting intersections. And then here's the variable length path. So we can say asterisk dot dot 200. So there can be a lower bound on this and an upper bound. But this is saying this pattern is saying the path connecting A and B through a bunch of intersections up to 200 intersections. And then we're calling the shortest path function, which in Cypher is going to look at the shortest number of relationships connecting A to B. And it's going to give me, if I go out of full screen mode here, it's going to give me that route. So let's zoom out a bit here. So here is the route that it found from the Duke Ellington Memorial to the reservoir. And I have latitude and longitude, and I can also see for each of these intersections. So this is an intersection of two ways, and I can see furthermore, if I traverse out, like which ways intersect with that one and so on. And each of these route relationships, if we inspect the properties, has a distance. So in this case, the distance from this intersection to this intersection is 12.9 meters. From this one to this one is 290 meters. So these intersections are not evenly spaced, and the Cypher shortest path function, well, this was just looking at the number of relationships that I'm traversing. it's not necessarily giving me the shortest weighted path. So in distance terms, it's not necessarily going to be the optimal route that I want to take. So in that case, we may want to use, and I'll jump to this query, we may want to use what's called Dijkstra's algorithm. So Dijkstra's algorithm is a shortest weighted path algorithm that we can use in the GDS library. So GDS, this is Graph Data Science. This is a library of procedures for Neo4j that sort of extend the functionality of Cypher, that allow me to run more complex graph algorithms. So when we're talking about this spectrum between operational workloads and analytical workloads, where we're talking about analytics being global graph operations, that's where GDS comes in. So we're saying GDS alpha shortest path. This is the Dijkstra shortest weighted path algorithm, where we're looking at the distance property as having the weight. And so now if we run this, escape out of full screen mode, we get back, this is just pulling out the latitude and longitude of each node along the way, but it's also now taking into account the cumulative cost, or the distance that we're traveling in the path. And it's saying that, well, the distance is 1,500 meters, so just under 2 kilometers from one point of interest to the other. And so when we're talking about routing, this is going to be a much better algorithm than the Cypher shortest path, where we're only looking at the number of relationships that we're traversing, not the total cost of the path. Anyway, so the point I wanted to get across there is just looking at some of the tooling that we use, Neo4j browser, Cypher, the various plugins that we have available to us in Neo4j, like the Graph Data Science plugin. Okay, so that I think is a good overview of Neo4j. If we skip ahead in chapter 1, what are we missing here? We talked about Apollo server, building resolvers. Yeah, okay, what we build. Let's zoom in here a bit. So this is chapter 1 in the book, where we're just sort of introducing the concepts of the different pieces of the technology in GRANDstack. So GraphQL, React, Apollo, Neo4j database. And what we do in the rest of the book is seeing how these technologies fit together to build an application. And specifically, we look at building a business reviews application. So something where we're keeping track of businesses and business details, writing reviews of businesses, searching for businesses, and then showing personalized recommendations for the user. And so what I want to do now is work through the exercises for chapter 1. So let's go ahead and do that. So there's three high-level exercises here. One is writing some queries against the movies.grandstack.io API, which we looked at a little bit, and then see if we can write some type definitions for the business requirements of our business application, and then downloading using Neo4j Desktop, Neo4j browser. We did that a bit, and working through a sandbox example. Okay, so that's what we'll do next. Let's see if I missed anything in the chat. Oh, good. Sounds like a few folks have found the book useful already. That's great. Good to hear. And then a question. The reason why a search by FID of type ID non-nullable value would not work. And then an example query for a therapeutic product by ID. Yeah, I'm not sure. I'm not sure what the context is there. Are you maybe looking at is that specific to the COVID Graph API? Maybe you can give us a bit more info on that one. Okay, let's jump over to movies.grandstack.io and see if we can answer these questions from the exercise. So let's make this a bit bigger. Okay, so open the Docs tab and the Schema tab to see the type definitions. Yeah, so we looked in Docs and we saw that we have both queries and mutations. So queries, these are the entry point for the API, so we can start searching for movies, genres, actors, or users. And then, for example, movie can take a bunch of optional arguments. And so what that means is if we want to search for a specific movie by ID or by title, we can include that, or we can specify a filter argument. And if we jump down to movie filter, we can see that there are lots of different filter arguments that we can use here. So basically, looks like we have a filter argument for each field on the movie type. So we can search by ID. We can search not just for an exact title match, but we can do a contains or a starts with. So these string comparison operations for the title. And then for numeric fields, we have less than, greater than, and so on. So this filtering functionality is quite powerful. We haven't talked about how this API was built, but we can assume that it was built using the Neo4j GraphQL integration. So if we look in the docs here for search for filtering, complex GraphQL filtering, we can see here some information about the filter argument. So this is, I'll drop a link to this in the chat. So that filter argument in this documentation page, this might be useful as we're working through the exercises to see what filters are available. And one thing I like about the GRANDstack docs is that it includes Graphql for some examples. So we can run queries using Graphql in the documentation, which I think is quite nice as a learning experience. But anyway, there's a table at the end of here that shows all of the different filter functionality that we can use. Okay, cool. So that is the type definitions. Let's see if we can write some queries. So find the titles of the first 10 movies ordered by title. Okay, well, if we look at the docs, I think we want to start with movie. And movie takes a first argument that allows us to do slicing. So I think what we're going to want to do is say movie first 10. So that's going to give us the first 10 movies, but these are not ordered, or order of these is not guaranteed. And if we start looking at our arguments, and if we do a control space, we can take a look at some suggestions. And again, this is powered by that introspection functionality of GraphQL, which is really quite nice. And I see there's this order by. So let's say order by, and then again, I can do a control space to see the options for how I want to order. And we want to order by title. Title descending or ascending. I guess ascending probably makes sense in most cases. Yeah. And we can see we have some special characters. So here's an escaped double quote. Here's a single quote. And so we start with those first. If we return the first 100, we can see, yep, then we go alphabetical and then start with A and so on. So, okay, cool. That is giving us the first 10 titles ordered by title. Next up is who acted in the movie Jurassic Park? Well, first let's figure out how to query for Jurassic Park. So we can say where title is Jurassic Park, and that gives us Jurassic Park. We could also use the filter argument and say filter, and then again, control space, where title contains Jurassic Park. And now this is going to give me Jurassic Park 3, and Lost World, Jurassic Park. Okay, but the question was who acted in it. So if we go back to the documentation, and if we look at the movie type, movie is connected to actors through the actors field. So I think that's what we want, is to add to our selection set the actors field, and then we'll need to pull in their names. And here we go. Now we have the name of the actors for each of the Jurassic Park movies. And the next one, what are the genres of Jurassic Park? Okay, well, I don't think I need to go to the documentation. Again, I think I can just use autocomplete, search for genres. Genres have a name. So let's minimize actors there. So we can say for Jurassic Park, we have thriller, sci-fi, action, adventure, and we get, I think, pretty much the same for the other Jurassic Park movies. And then the second part of this question, what other movies are in those genres? Well, again, we just keep adding to the traversal of the data graph in our selection set. Now, nested under genres, we can add movies to traverse out to the other movies in each of those genres. And we get back a lot of data, so we can say, maybe give me the first 10, order by year descending. So give me only the most recent 10 movies in each genre in this case. And I can add year to verify that's what's going on. Cool. Okay, and the last question for this section, what movie has the highest IMDb rating? Well, let's start over with a new query. So I know we're going to want to search for movie. We'll bring back title. It says highest IMDb rating, so I think we're going to want an order by. And IMDb rating is a field, so I think if we say IMDb rating descending, let's give me title, and then let's also return the IMDb rating, and then let's just return the first 10 of those. And if we run this, we can see, oh, well, we get a bunch of nulls. So in whatever ordering system that we're using here, it looks like we're ordering nulls before we are actual float values. And I think this is not super useful. In our application, we probably, if the user selects sort by IMDb rating, show me the highest first, they probably don't want to see a bunch of null ratings. So let's filter those out. And in this case, I'm going to use the filter argument. Let's bring this down on a new line so we can see this a bit easier. So I said, the documentation here would help us. So we could look at the example in the documentation to figure this out, or we could play around a bit. But if we look at the tab completion here, well, I know I want to filter out something related to the IMDb rating. So I have a bunch of options here. Less than, greater than, if it's in a list of values, if it's not in, let's say IMDb rating not, what can I say? Filter where that value is not null. And I can see, yep, that works. So now this says, find movies ordered by IMDb rating, give me the first 10, and filter out any movies where the IMDb rating is null. Filter those out, and we get back Band of Brothers with 9.6 as the highest IMDb rating. Okay, cool. So that was a little bit of figuring out how to write GraphQL queries. If we look at the next question in the exercises, it says, consider the business reviews application we described earlier in the chapter. See if you can create the GraphQL type definitions necessary for this application. Yeah, so this is a good one. So the business requirements, so we said we're going to build this business reviews application where we want to be able to list businesses and business details. We want to have users writing reviews that are connected to the business. We want users to search for businesses and show personalized recommendations to the user. Okay, so those are our business requirements. And the exercise is to write GraphQL type definitions that address these business requirements. So there are a few different ways that we could approach this. If we take a look, I think we kind of skipped over this. Let's take a look at learn, schemas and types. So we skipped over, I'm trying to see if there's a good page that documents the SDL. I guess SDL is used throughout here. Yeah, so maybe there isn't a great page in the docs there that gives an overview of SDL, but SDL, this is the schema definition language that we use to define our GraphQL schema, so the types, how those types are connected, and then the entry points. And there's a couple ways to approach this, right? I think that it's helpful. We're thinking in terms of graphs here, and as they say on graphql.org here, we're modeling our business domain as a graph. So we can either start writing these type definitions in SDL, but I like to think a bit more visually, and there is a tool that I like to use. I'm just clearing out the previous example that I had in it. Oh, it's not that bad. We can load it with this one. That's fine. So there's this tool called Arrows. Drop the link in the chat here. So Arrows is a fairly simple application that allows us to draw graph data models. And it's helpful, I think, for just sort of thinking in terms of graphs, which is helpful when we're starting to reason about our application data model. So this is typically where I start with any data modeling exercise, whether I'm using Neo4j or not, and this is structured to help us think in terms of the property graph data model, but that's not necessarily a strict requirement, as we'll see. So let's start to think about. So I'll delete this node and delete this node. Arrows uses local storage, so it stores your data model in local storage in your browser. So if you close the tab and come back to it, it'll still be there. So if we look at the requirements of our application, as well, we need to keep track of businesses and business details. So so I think we're going to need a node that is going to represent businesses and business details. So what sort of details are we going to have? Well, we'll probably have like the name, the address, the location, which might be like a latitude and longitude, maybe the hours that the business is open, which we might keep track of as a list of integers, maybe something like that. And then we want to allow users to write reviews of these businesses. So when I go through starting out to build a data model, the first step is, in my mind, I think, to identify what are the entities in the business requirements. And those in the graph become nodes. So here we've identified businesses. Now we're talking about users. So I think we're going to need a user node, and users have a name, and then reviews. Reviews are another entity that we're talking about here. So a review is going to have like a rating, like stars or something. Maybe that's an integer, 0 to 5 or something, and then maybe text that's a more description of the review. So this data modeling I think of as an iterative process where I'm starting out defining the objects, those become the nodes, and then I start to think about how are these connected, and those become the relationships that we want to think about. So a user and a review, those are definitely connected. So we can say that a user maybe writes a review, and that a review, well, a review is connected to a business, right? So we can say that a review reviews a business. And then the next step in the data modeling process is to say, okay, given this data model that I've defined, can I imagine a traversal through this graph that answers the questions that I want to ask of it? And so what are the questions that I have to ask of it? Well, that depends on my business requirements of the application. And in this case, listing businesses and business details. Okay, sure, I can like search for all business nodes and grab the name, address, location, hours as details. Okay, sure. Is that useful enough to the user? Well, the user probably wants to know maybe what genre of business this is, some classification system. So I should probably think about that. So maybe something like a genre property. Now, another question that comes up a lot in data modeling is, okay, I have some attribute of a thing, an attribute of a node or a relationship, and the question is, well, should I model this as a property on the node, or should this be modeled as a node itself with a relationship connecting it? So genre, I think, is a good example of this kind of choice. So genre is describing the business, right? So, or maybe instead of genre, that's more specific to the movies, I guess. Let's call it category. So category might be like bookstore or restaurant or brewery, cafe, breakfast restaurant, diner, that sort of thing. So it's specific to a node, specific to a business node. But the question is, well, should I model this as a property of the node, or should this be a node itself that I then connect to the node through a relationship? And for me, the answer to this question comes down to, well, if I traverse through this new value, can I discover something useful? If the answer is yes, that I can discover something useful by traversing through this a new value as a node, then it should be modeled as a node. If not, then it probably should just be a property. And category is a really good example here. So if I store a category as a node itself, so let's say if I have business and category, and I say something like business is in category, and category has a name, which is like grocery store, restaurants, whatever. So now the question is, well, can I traverse through this category node? And in this case, a traversal through a category node would be to other businesses, right? So it would be something like this. Can I discover something useful? And I think the answer is yes. So if I want to know to this point where we want to not just search for businesses, but show personalized recommendations to the user, well, if I know a business that a user likes, like let's say this user is writing reviews for breweries frequently, I can then traverse out from the businesses that this user has written a review of to the categories of those businesses, and then traverse along those incoming in-category relationship to other businesses, and I can then generate personalized recommendations for that user, right? So I know all the businesses you've written reviews of. Here are other businesses in those same categories. Or I can even go out 2 hops further. So businesses that are in categories that are also co-occurrence categories with businesses that you like, right? So I can start to think of some more complex traversals to uncover information that is useful to our application that I really couldn't uncover if I was just modeling, like categories as a list of strings here on the individual, as a property on the individual node. I wouldn't be able to do that traversal to find something useful. So anyway, so when the question comes up is, okay, I have some data that I want to model. Should it be a property? Should it be a node itself? If I can traverse through it to find something useful, it should probably then be its own node. Okay, so that's sort of the iterative data modeling process, is look at the business requirements, identify the entities, those become nodes. How are those entities connected? Those become relationships. Looking at the model, can you think of traversals through that graph that answer the questions that arise from the business requirements? If you can't, then maybe think about tweaking the data model to be able to answer those questions. And once you can think of a traversal through the graph to answer all of the questions that you have based on the business requirements of your application, then you have, I think, a workable model. So it's really this iterative process. From the chat, you should turn arrows into an integrated Neo4j product. I would not be using Neo4j without arrows. Yeah, it's interesting. Like arrows itself. So APC Jones, he is Alistair Jones. He's the creator of this version of arrows, which was written many years ago. He's now an engineering manager at Neo4j. I think hasn't touched this version of arrows in many years, because it's really a simple application, but is extremely useful, I think, for just being able to diagram and reason about these data models. And your suggestion of integrating Neo4j as a product is a great idea. I won't steal any thunder there, but I would be surprised if we don't see some sort of diagramming model. If you are at Nodes, the Neo4j conference, Neo4j online conference, specifically the Neo4j Online Developer Expo and Summit, Nodes 2020, you may have seen a talk from my colleague Eric. So here's the content hub, where he showed Cipher Workbench. Drop a link to this in the chat. And so Cipher Workbench is kind of like arrows on steroids, I guess. So Cipher Workbench is, let's look at some screenshots. So Cipher Workbench is this data modeling tool for Neo4j that allows you to define these data models, to share them, to collaborate on data models as a team, to export them as Cipher, and then there's also a visual Cipher builder functionality that he's working on that allows you to construct Cipher queries visually, which is quite cool. Oh yeah, and this is Cipher Workbench is a GRANDstack application, so built on top of the tools that we're talking about today. But anyway, so I'll drop a link to this in the chat, because Cipher Workbench was demoed in that talk at Node. So if you want to see some examples of more advanced data modeling tools that are more tightly integrated with Neo4j, Cipher Workbench is a great example. Another question in the chat: will you be covering Apollo client caching and things to watch out for when using Neo4j? Yeah, that's something I think in the series of book club sections that we're going to do. I think because the chapters in this excerpt, so the 3 chapters we're working through initially, these ones, focus I think a bit more on the back end. So today we talked about the individual components. Next time we'll dive more into using Neo4j and specifically the client drivers. So how do we build applications? We'll look at the JavaScript driver for Neo4j, and then chapter 4, which is looking at building GraphQL APIs with Neo4j. So because that's the focus of these 3 chapters that we're working through as part of this Fullstack GraphQL book club series, I think that we won't dive into some of the specifics of things in the clients like caching. We'll definitely talk about things to watch out for when using Neo4j. We'll go deeper into Neo4j, I think, than we will things like Apollo client caching. But that's definitely a good topic. In some of the other streams that we do, so where we're building applications using GraphQL and Neo4j, we'll definitely bring stuff like that up. I don't think we've talked much about specifically some of the Apollo client caching on any of the projects we've worked on so far, though. But that's a good one. So I'll make a note of that topic. That's definitely something that we should dive into. So how do I get Cipher Workbench? Yeah, that's a great question. I think Eric says specifically at the end of the talk how to get early access to it. I think right now it's not been released yet. I think it's currently in private beta with like a few dozen users or so, but I think Eric is planning a public release sometime in the next few months or so. I don't know, if you watch the talk somewhere at the end, I think he talks a bit about that. So short answer though, I guess, is try to get on the private beta. Otherwise, there'll be a public launch sometime in the next couple months or so, I think. But yeah, it's a super neat tool. Okay, so we have this graph data model that we talked about, and we talked about this iterative data modeling process that we go through of sort of taking the business requirements of our application and identifying the entities, how they're connected. Can we reason about a traversal through the graph that answers our questions? If not, we need to iterate a bit. But specifically, the question in the exercise was asking about creating the GraphQL type definitions necessary for this. So what is this pretty picture that we drew with arrows have to do with GraphQL type definitions? Well, I think because with GraphQL, we're modeling our business domain as a graph, that really this visual process is the starting point for creating our GraphQL type definitions. Because now that we have this, we can then open up, let's open up our editor. I'll just create a new file here. Sure, it's fine. Let's call this schema.graphql. And now we can convert this to GraphQL SDL. So with SDL, we define our types. So in this case, we're basically going to define a type for each of these node types we've identified. So user, review, and business and category. Stop and close this. I think we're done with our React application. Oops. Schema GraphQL. There we go. And category. Okay, and then we've named some of the fields here. So user has a name. That's a string. Now in GraphQL, we can define fields as optional or nullable or non-nullable. And we do that with this exclamation, this bang here. So this is saying that string is a that name is a non-nullable string. So every user must have a name. That makes sense. We can also define IDs. So maybe we have a user ID that is of type required ID, and maybe we don't have to have a name. So when we first create a user, maybe we don't know what the name is, but we can auto-generate an ID for the user, and that's always going to be required. Oh, I wrote user twice. This should say review. And a review is going to have a rating that is an integer and text. That's a string. And we probably always want to have a rating for the review, right? Like we need to have some numeric value associated with it, but maybe it's optional for the user to add a text description. Okay, then for the business, I think similarly here, we want to have a business ID. So GraphQL has a ID type built in. So business needs to have an ID. And then, maybe it should have a name and address, but maybe those aren't required. And then location. Well, we said point, but what is a point? Well, there's no built-in point in GraphQL, but we can define our own custom scalar. So let's define a scalar point. And we'll talk about what that means and how we can work with point types later on. But for now, think of this as a latitude and longitude pair. Okay, and then category. And category is just going to have a name, and that's going to be a required string. That's going to be something like bookstore, coffee shop, that kind of stuff. Okay, so the thing we're missing though are these relationships. So how are these fields connected? How are these objects connected? That's where the relationships come in. So a user maybe has a reviews field, and that's going to be a list of review objects. An individual review is written by a user, and that's going to be required. We can't have a review without having an author. Similarly, a business is going to have reviews, but that's nullable. Some businesses won't have reviews written. And then businesses are going to be connected to category nodes. So one or more, 0 or more categories. So it's going to be an array type. And then the category is going to be connected to business. Right, so I can go from the coffee shop category, find me all the businesses that are in the category coffee shop. I can do that traversal in the data graph. Okay, so that defines the data, but what about the entry points? So specifically, we need to search and list businesses and show personalized recommendations to the user. So those are going to be entry points in a special type called query. So when our application queries the GraphQL API. We maybe want to search for businesses. So maybe we have an entry point that is something like business search that takes a search. Maybe it's a search string. And it's going to give me one or more businesses. So I want to search for businesses by keyword, maybe in the application as a simple example. So search, that's the search string argument for the business search query. And it's going to give me businesses as a result of this search, let's say. Okay. And then the next one, the next business requirement that we have is to show personalized recommendations. So in this case, maybe that belongs on the user type. So, so a user, we're going to show recommendations, and those are going to be businesses. So maybe something where we want to show something like the current user. So current user, this is going to fetch the currently authenticated user. It's going to give me a user object. And then I want to generate recommendations, personalized recommendations for that user. Well, I'm going to then query the recommendations field on the user type, starting from current user. Now, we haven't talked about how we would implement this. We'll get to that in chapter 4. But in terms of the type definitions, this is, I think, a pretty good starting point. We've identified the basic data that we need for our business reviews application. We've thought about the entry points that address the business requirements that we have identified. So I think this is a good starting point for the type definitions and the GraphQL SDL, Schema Definition Language format, that we want for our API. So let's move on to the final exercise, which says, download Neo4j and familiarize yourself with Neo4j Desktop and Neo4j Browser. Well, we did that already. We looked at that OpenStreetMap data set in Neo4j. We looked at Neo4j Browser, looked at Neo4j Desktop. Download Neo4j, well, we said that if we just go to neo4j.com/download, that's the default download is Neo4j Desktop, which we can download for free and start playing around with Neo4j. Okay, great. Check that off the list. And then the next part of that is work through a Neo4j Sandbox.com example dataset guide. So what is that? Well, let's go to Neo4j Sandbox.com. So Neo4j Sandbox, these are hosted instances of Neo4j that come preloaded with a data set and an interactive guide that embeds queries and images to walk us through how to explore that data set using Cypher. So I'm going to launch the free sandbox, and I think you will need to sign in to Sandbox. I've already signed in. The reason that we ask you to sign in is because all of these instances that you can create, so I have two running here, this OpenStreetMap one that we were looking at previously, and then a fraud detection, which has some fake bank data. But all of these different projects that I can create, these spin up hosted Neo4j instances that are private to you. So it gives you exclusive access to your database that you can connect to, write and build applications against. So anyway, that's why you have to sign in. There's lots of different use cases we can spin up. We can spin up a blank database, Twitter, that allows us to import our own personal Twitter data, which is kind of fun to play around with. And then there are movies, I think is the simplest example, that has a smaller data set of movies and actors. But then there's things that show off the Graph Data Science library, the Panama Papers data set from ICIJ. ICIJ uses Neo4j for investigative journalism. And this is the data set that came out of the Panama Papers. There's also, I think, the FinCEN. Yeah, the FinCEN files, which is the data that ICIJ released through that investigation. Anyway, I'm going to choose the recommendations data set. This is a good one because we said that we need to show personalized recommendations in our business reviews application. Recommendations might be a good one to look at. So this is spinning up in a container somewhere, hosting our Neo4j instance, spinning that container up, loading the recommendations data set, and now making that available to us. So I can see here, if I click this down arrow, I have the connection details. If I want to build an application using the drivers that connect to my recommendations data set, I can see how to do that. I just want to open it in Neo4j browser for now, so we'll click that. And so this will load Neo4j browser, automatically connect to that sandbox instance. It passes a token behind the scenes that has the credentials to Neo4j. That's why I don't have to type in my username or password. And then it gives me this guide that has some pretty pictures and explanations of what's in the data set. It embeds queries that I can click on to execute those queries. So Sandbox, Neo4j Sandbox is really nice for a few reasons. One is that it gives me Neo4j instances in the cloud that I can build applications against, comes with preloaded data sets, or I can load my own data, but then it also has these guides that show me how to use Cypher to query the data set. So in this case, this query that I ran, this was searching for movies that contain, where the title contains the word matrix, finding all the users who rated those movies, and then counting the number of reviews. So there are 259 reviews of The Matrix, 82 of The Matrix Reloaded, and 54 of the third Matrix movie, just as an example query. Okay, so this data set, this recommendations data set that we loaded, has data about movies, users, actors, and genres. Okay, cool. And this will show us how to generate personalized recommendations using two approaches: content-based filtering, so finding items, in this case movies, that are similar, or collaborative filtering, where we're using the preferences of other users to find items to recommend. And it shows a couple example queries of very simple queries that we can run to find personalized recommendations. Cool, and it shows us some more advanced options using some algorithms, and even I think some things from Graph Data Science. Cool, so I won't go through all this. I'll leave that for you to explore. I think that is more fun with Neo4j Sandbox, if you explore those on your own. But okay, I think now we've worked our way through all the exercises. So that was a look at chapter 1 of the Fullstack GraphQL book. The next section, which will be next week, so next Thursday. So this is the regular Will streaming on the Neo4j live stream hour every Thursday at 2 p.m. Pacific. So next week we will pick up with chapter 3, which is a deeper dive into Neo4j. What I want to look at specifically, though, is how do we use the client drivers to build applications, specifically JavaScript. We skipped chapter 2. Chapter 2 is a bit more about how we build GraphQL server implementations. So maybe we'll talk a bit more about that next time as well, without looking through the book. Again, if we look at the table of contents, the reason we are skipping chapter 2 is it's not included in this Neo4j sponsored excerpt, which is okay. That allows us to get a bit further. So this was the first iteration of the Fullstack GraphQL Book Club. I hope this was interesting and useful for folks. Thanks for sticking around. If you missed this at the beginning, this is the URL to download this free ebook version. So bit.ly fullstack-graphql-ebook. This is a free excerpt of 3 chapters of the Manning book, Fullstack GraphQL, and we are working our way through it in the live streams as part of Fullstack GraphQL Book Club. So if you missed it and didn't get the book for this session, you can download it there at that link that I shared in the chat, and we'll pick up with chapter 3 next week, taking a deeper dive into building applications that use the Neo4j client drivers. Maybe what we'll do is next time set the goal of using Apollo server to build a naive GraphQL application, showing how we can manually implement those resolver functions that we talked about. So that then when we get to chapter 4, which talks more about the Neo4j GraphQL integration, we get some appreciation for some of the things we get for free with that integration. So maybe that's what we'll focus on next time. But anyway, thanks a lot for joining today. I think we will call it good there. Thanks for sticking around, and hope to see you next week. So have a good end of the week and weekend, and see you next time. Cheers.